Okay, hello, you're welcome to my channel. Now in this video, we want to look at some examples, right, under limits at infinity. So I made these particular examples a bit general ones, so that when you see any function of these forms, all right, you know their corresponding limits. Good. So I said for any n bigger than 0, so let's say n is just in a set of real numbers, that is, n can be a whole number, a fraction, or whatever number, but it's bigger than 0. Good. It's not 0 and it's not a negative number. That is what it means. Then the following limits are true. Now the first one is that the limit of x to some power n, right, as x approaches infinity is infinity. So this first example, this function is a power function. You say x raised to any power, all right, where the power is actually bigger than 0, that as x approaches infinity, as x increases without bound, the result of the limit also increases without bound. That is, it's also equal to infinity. So maybe if I give an example to illustrate that, so let's say limit of this function as x tends to infinity of, let me give you a typical power function. We have x raised to the power 3, right? That is just x raised to some power, where that power is bigger than 0. Good, great. So this is, now what this tells us is that you are given a certain input that is increasing, is getting larger, and that input, you raise it to power 3. What do you think will happen to it? It will increase even larger, right? Because we said this approaches infinity, so this is bigger than any real number. So again, the second one has it that the limit of x raised to the power n, now in this case, as x approaches negative infinity, so you know how we can increase towards the positive axis and then also increase towards the negative axis, all right? So it's a very big or it's a very large negative number. Let's look at it that way. So as we raise that number to some power n, given that n is bigger than 0, right? Now, the result is going to be, that's an equality sign for you. The result is going to be infinity if that power is an even number, right? Or the result is going to be negative infinity if that power is an odd number. Good. Let me give you one example to illustrate what I'm talking about. Let's look at n if it is an even number. We look at the limit of x raised to the power 2 as x approaches negative infinity. Great. In this case here, the power is an even number, all right? Good. So as x approaches negative infinity, we can look at this. Now note, infinity is not a real number, right? It's only a notation, or it's only a fact that illustrates or that tells us an increase without bounds. You keep on increasing and increasing just like that. But for understanding, we can use a very large number, right, to illustrate it. Square a negative number, you get the result to be a positive number, right? And then, since it's a square of that big number, the result is going to be the square of it. So we are going to be talking about infinity also, because as x is a negative number, if you square, the result is going to be positive. And since the magnitude is infinity, the result is still going to be infinity, all right? Good, great. So that's it. And then the next one is that x raised to the power n will be negative infinity if n is an odd number. So you look at this, as x is approaching negative infinity, let's take n to be a very large negative number. If you raise it to some odd power, let's say to power 3, right? As x approaches infinity or negative infinity, if you raise it to some odd power, given that this is negative, right? You know, if you raise a negative number to an even power, the result is going to be positive. If you raise a negative number to an odd power, the result is going to be negative, right? So if you raise, let's say, negative 2 to the power 3, the result is going to be negative 8. So here, the result is going to be negative. As you're talking about infinity, you take it raised to the power 3. In fact, the result is still going to be negative infinity. So that's what it means from this number 2. Good. Then the third one tells us that the nth root of x as x tends to infinity is also increasing without bound. So let's look at this to be a square root, all right? Good. The square root of something, let me give you a curve immediately. The curve looks like this, all right, for non-negative output. The curve looks like that. It is increasing, but at a very slow rate, all right? It is increasing as the input increases, the output also increases, so this tells us that the limit of this kind of function, in this case, this is just a square root, all right? This is square root of x. We can talk about cube root, fourth root, and so on like that. Good. So it's going to be also infinity. It's also going to approach infinity. So whenever I see something like this, let's say square root of x or fourth root of x as x approaches infinity, the result of that limit is also going to approach infinity. Good. Now let's look at the fourth one. The limit of this kind of function 1 over x raised to the power n as x approaches positive infinity or negative infinity, the result is always going to be 0. Good. Okay, so whether n is positive, whether n is odd or even, it doesn't really matter in this case, because now 1 over x, right? As x approaches infinity, the result is always going to approach 0. You know, when the denominator of fraction increases, the result of fraction approaches 0. So whether it's increasing towards the negative axis or towards the positive axis, the result is still going to approach 0, right? But the only thing is that it's going to approach 0 either from left or right. So maybe I can break this apart into two. Let's look at the function to be 1 over x. So we're going to say the limit of 1 over x as x approaches infinity, all right? This is going to be 0 from the right. Good. And then the limit of 1 over x as x approaches negative infinity, this is going to be 0, but this time from the left. Anyway, that's just it. Just have to take note of it, all right? Good. This last one also follows the same way. It's just that this has a sum root, right? But whichever way, as you look at it, it's still going to be 0. Good. But one thing you should note about this root is that if you're having a square root or an even root, right, the input should be positive infinity, should approach positive infinity. If it is approaching negative infinity, then this root should be an odd root, like the cube root or the fifth root. Otherwise, this value is out of the domain of that function. Anyway, that's better. All right, thanks for watching. Please subscribe to my channel.